right, so doors are closed. We have a full house, almost a full house, so great. We'll be talking about distributed tracing in .NET and in Azure. The plan is to just kind of give a lay of the land, what's available right now, and obviously we are future tech, so we'll also want to discuss a little bit about the future of distributed tracing. My name is Annejan. I work for 4.net, which is a consulting company based in the Netherlands. We're delivering experience and knowledge, expertise in the Microsoft stack, so that's basically .NET and Azure. And I'm lucky enough to work with interesting customers, a solution architect, software architect, cloud architect, give it a name, developer. Well, as said, we want to talk about distributed tracing in the next 45 minutes. So if there's any questions, please do ask them, raise your hand, or well, draw the attention or whatever. This can be a conversation if you want it. So when we talk about distributed tracing, we're basically talking about one of the pillars of observability. It's kind of a thing lately. Observability is really about logging, tracing, and metrics, and tracing is then distributed tracing. Basically, what we want to do with distributed tracing is get an overview of an entire, well, business process, if you will, that maybe spans multiple components in your solution. And only by having distributed traces, so having the ability to really trace the flow of a process all the way through these different components, can you get a clear-cut view of well, how things work within your system. Logs obviously are, well, they're not unrelated to tracing. As a matter of fact, they seem to be almost conflated if you look at stuff like application insight, where if you do a log entry, that's actually landing in a traces table. But logs are really different beasts conceptually. Logs are more about logging interesting events that happen within your application, things of interest, maybe errors. Those would be the things that you would want to log. And metrics can be, typically are aggregated data points, numbers, technical ones such as, well, processor usage, memory usage, but also functional ones, numbers of orders processed or numbers of, well, mouse clicks maybe. But today we're really going to focus on tracing. And for that, I've devised this kind of fictional application or fictional solution that's, well, fulfilling an order flow. Basically what we would have at the top is an application. I'm actually not good at front-end application, so I didn't build an application. I'm just using Postman to place orders against my ordering API, which is an Azure function in this particular case. Don't take this as an advice to do all your APIs and Azure functions, which seems to be all the rage these days. It's not generally a good idea, if you ask me, but for now, for speed of development, speed of demoing, this is a function. So I use the places an order. That order is maybe undergoing some pre-processing, and that's then being sent to a service bus topic, from where two things happen. First of all, the subscriber picks up that order for further processing, maybe makes calls to an inventory API to make reservations for particular stock items, after which the completed order is being stored in a Cosmos database, which is then emitting changes for an order fulfillment processor to do stuff. And in parallel, we also have a customer loyalty processor that's also processing orders, more for the purpose of, well, maybe awarding points for a customer for discounts for the next time they come around or something. So this is kind of the solution that we're going to talk about today. I'm going to illustrate several bits of distributed tracing that's really, for the most part, already there in the framework, in the SDKs that you use, etc. So I think this is an interesting time to do a show of hands. Who has ever built, or maybe is building now, or has worked with a team that has ever built their custom correlation solution? So custom headers being sent around. There's one. So several hands. How much of you...
Downloading and service bus count.
Well, that's not really custom, right? So you're off the hook. But how many of you are still using some custom tracing mechanism right now of these hands? Still a couple of hands. Okay. Last question then. How many of you are not using a custom end-to-end tracing mechanism, but are just using like functional data points to trace process flow? So maybe uses an order ID or a customer ID or a user ID to... Okay. Again, a couple of hands. Okay. Well, I'm here to tell you that if you're in the Microsoft ecosystem, I mean, that's maybe a big if, but with this crowd, maybe not so big, you don't really need to do that. You don't really need to build your own stuff, and you don't really need to resort to functional data points to do distributed tracing, because it's all at your fingertips. You have it. And to demo that, we'll be going through some scenarios, but first off, we're not going to look into this in too much detail, but just note that basically all these functions are all acting as APIs, and they are all connected to an application insights instance, where every component talks to its own application insights instance. There's a bit of a, well, maybe debate is too big of a word, but some people feel that basically this should all be pointing to a single application insights instance. Well, that maybe has its merits, but it's not really needed. Also for end-to-end tracing, it's not really needed. And metrics tend to be relevant for a single component. So metrics and application insights tend to get mixed up and tend to get less valuable if you shove all your stuff into a single application insight instance. But really, different discussion. I see two people here having had this discussion before, I presume.
We are working at Green Choice, and they are having a one single application insights, and every application, I mean like maybe 20, 30 applications are logging in the same instance.
How's that working for you?
It's horrible.
Okay. Thanks. Don't have to make that point myself then. Cool. Okay, so this is what we'll be looking at. So let's just try and place an order. As I said, I'm using Postman as a application. I don't build front ends, or at least not for fun. And they're not good looking as well. So this is good enough for now. So I'm just setting an order with product ID 1. When I do that, I presume it needs to wake up, but then I'm getting a 200 OK, and the notification that an order has been created. Now, this is obviously logging into application insights. Those of you who actually work with application insights know that it can take some time before it actually ends up there. So here's one I made earlier. Going through that one, and we're starting off easy. So we're just seeing how, should be this one, run. I said this one is from yesterday, but what we're seeing here are requests and traces right there. So there's a top level request. It's basically the entry point into the API, and then traces, which include my own logging statements, but also trace statements from SDKs, etc. I've filled that a bunch out because otherwise it's really going to be unreadable. But this is, and the point I'm trying to make here, just to start us off easy, is that they're all kind of related through this single operation ID. So this one identifier is telling you, okay, all these traces and also these log messages that end up in a tracing table, they're all correlated for the single request. Right? So to get back to this one, oh man, I'm going to have to do that every time. It's going to be annoying real fast. We have a single operation ID. And that works because this is kind of the data model for application insights. This is how application insights is well, basically modeling everything that's going through it. Every request starts with an actual request, which is logged as such. Going into the application, an application can have dependencies going to downstream system. We'll take a look at those in a moment. Can maybe emit exceptions if something goes wrong in the world, and emits traces and metrics and events. We'll not really be talking about events today, also not really about metrics, but they are there. And all this stuff is all wrapped up in a single operation, which has an operation ID. Right? So far so good? All right, awesome. That's not awesome. I've seen this before. So just reconnecting it. I'm hoping it's not my laptop. I'm hoping it's the connection actually. Oh, if it is my laptop, maybe get a new one. If his past history is any indication, it will come up shortly. Yes, there it is. Now I've lost it here, which is also kind of annoying. Oh, there it is. Okay, cool. So this is the single order API with a single application insights instance, with a single request, single operation ID. So that's not really distributed, right? This is just one thing. Let's order another product. I've actually built this, so I know this will break. And obviously the order API is all fine with that. It's sending it to that service bus topic. But then through maybe some dashboard or something, I'm actually made aware that the order processor at this point has generated an error. So let's dive into what that error is. And again, not waiting for this one to actually end up there, but going for a previously created one. Finding my logs again, and then picking up this particular one. So now I can see that somehow I'm generating an exception right here. And I can also see that moments before that, I made that call to that inventory API, and that has been returning a 400. So a bad request HTTP response code. Typically that's not good, but now obviously I'm going to be interested in, okay, then what happened in that API then that causes my processor here to fail? So now I'm going to be wanting to relate whatever's happening in this processor to whatever is happening in the downstream API. And actually, if I just simply add that inventory API to the same scope of the same query, I'm doing apply, I'm running it again, I'm actually seeing more stuff. Just scroll, let's scroll a little bit to the right and then see that right here we have an order processor, and then we have a couple of traces from the reservations operation, so that's actually the API. And then we're back at the order processor. And also note that these are all actually the same operation ID. Who was expecting that? Okay, but I'm talking about distributed tracing, so maybe I kind of gave it away, right? But this is, I didn't do anything special for this. This is just using, okay, latest version of libraries, but using .NET Core, .NET 6, I think it is, or maybe 7. Bland HTTP requests, just the functions, just listening on an HTTP trigger, and that's it. And it's in different application insights instances as well, and still I have that traceability. Now, obviously, if I now look into the code, or maybe first look at the actual messages, I can see that somehow I'm entering that API, and SKU item 2 is being reserved, but SKU item 2.1 is not eligible for reservation. So, well, that's probably where stuff went wrong. So then I can maybe look into the code and then see that actually in the order processor, right here, and this is hard-coded, but obviously if it's a real e-commerce system, that's probably going to be someone who has configured that whoever orders item 2 also gets SKU 2.1 for free. But in this case, it's a voucher. It's not something that can be reserved, etc. So it's misuse of the system, and now I know what happened. So back to these slides then. We have two different API application insights instances, but they're all sharing the same operation ID. So now the question is, how does that happen? And the answer is pretty simple. It's just that an HTTP call is automatically enriched with what's called a trace parent header. And that trace parent header has 4 segments. The first, I think, is versioning. So which version of this standard you're using. It's basically always 0 at this point. Maybe in the future it will change. Last one is whether or not sampling is applied. So whether basically everything is logged or telemetry is being sampled. Different discussion. The third is some identifier that we'll be talking about in 10 minutes, 15 minutes. And then the second part is that same operation ID. So it's basically simply a header defined, by the way, the W3C Trace Context standard. A trace parent header that is basically communicating over HTTP what the parent request is, basically. So that's the first standard, basically, that we are coming across if we're doing this. Now, we're just talking about the order processor and the inventory API, which is HTTP, which is, well, fairly simple, right? But what if we were to order product number 3? So what would happen then? If we do that, again, the order processor, or sorry, the order API at the top finds it all very amusing and just gives me a 200 OK. And then the same stuff is going to happen again. And again, I'm finding an error. So if I'm now, let's take a different route. And look at the exceptions here. And now I have to find the correct one. So the one from yesterday evening. I think it was this one. Yes, it is. Just take a look at what we see. I mean, from the top, we have the actual API that's sending a message to a service bus queue in this case, in my Annejan namespace, which mine, indeed. It's also logging that the message then being processed by an order processor, is logging the call to inventory API, the fact that it comes back with a 404 in this case, and the exception is being then raised by the order processor. Oh, and also, it's also connecting the customer loyalty processor to this all. So this is, out of the box, the full process all the way from the API through Azure Service Bus, so through a topic and a subscription. Topic and a subscription. So I'm saying queue, topic obviously, and a subscription, and the subscribers, and then downstream API calls after that as well. Who expected this to be out of the box available? A minority. Okay. So how then? How does that work? Where is this magic coming from? Well, this is what we saw. We basically saw that every component in there is being represented. And we also see that it's going, well, it has to have somehow been communicating through that message, which is indeed true, because if I were to look up that message, I would see that the Service Bus SDK has been friendly enough to put a custom property on my message. I'm not sure if this is actually perfectly visible in the back. Maybe this spices it up a little bit. A diagnostic ID is being sent as a custom property to my message, which is basically holding the same type of value that we saw from that trace parent header. So again, versioning thing that's not being actually used, an operation ID, then the identifier of the span above, and then whether or not sampling is in effect. Again, all done automatically through the SDK. Make sense so far? Everyone understanding what's happening? So if I'm now looking more closely into what's happening here, I can also expand OpenTelemetry here. Maybe not quite as nice a reading experience as just having a tabled output of application insights, the queries in the log, but again, I can now select, well, just give me anything from the API or give me anything from, well, whatever processor is in there. And if I'm now looking at this, I see that actually in the API, somehow, at this point, querying cache for SKU for product ID 3 and found SKU 4 for product ID 3. Well, I built a system, I know that this is not good. So apparently this is the problem in the API, which is ultimately surfacing in an inventory API. So let's just go back to that. In the inventory API, I'm getting a 404. This is raising an exception, and that's actually where the problem is. And I can find out because I have distributed tracing. One of the previous, yeah.
So now you're hooked on .NET 6 or 7 and on Azure. What if you change one of the APIs to, for example, Java? Can you
We'll get to that. We'll get to that. Good question. Because we're not all living in this fairy tale land with only Microsoft stuff, right? I understand. There's actually a solution for that as well. But let me get to that. First, let me draw the attention to that Cosmos DB thing down there. Because, as I explained at the beginning, we're having orders flowing through an API, flowing through a topic, and then maybe some stuff happens. At some point, if no exceptions occur, I'm saving this in an order in a database, and then off of that change feed of that database, something else downstream happens. Again, whether or not it's a good practice to use the change feed as an integration mechanism, well, that's up for another debate. But it does illustrate the point that if you've ever worked with a change feed in Cosmos, or for example, Event Hub, you know that typically you would process incoming events in Event Hub or incoming changes in Cosmos. You would treat them in batches. So now I have 10 requests flowing through that order API, all with their own unique operation ID. They're all ending up in Cosmos, or maybe Event Hub, in this case Cosmos. And there's one processor over there that's picking up these 10 processes, these 10 orders, correlated to 10 processes, but this is running in a single process. So now I have a one-to-many relationship. To which operation ID will I correlate this downstream processor, right? Everyone sees the problem? For Cosmos, that actually doesn't work out of the box. So now I'm going to show some code to make this work. If you would use a change feed, and I'm really just showing that code because it's instructive. Both how Event Hub does it like that out of the box. And it kind of illustrates what you need to do, and it also kind of illustrates that this is extendable. You can hook up your own stuff. For example, Service Bus works out of the box, but if you use storage queues, then it doesn't work out of the box. Not sure if you should be using storage queues, but some people do. And then you would also have to build your own correlation mechanism, but not from scratch. You would hook into this one. So let me first, I'm first showing the code. So we are in the order processor, which is then inserting stuff in Cosmos. And what we're doing, basically, is creating a dependency using the application inside telemetry client, documenting it with a particular type of string so that in 5 minutes I can also show that a nice icon shows up in the transaction search, but this is all cosmetic. Yes, I can zoom in a little bit. And well, this is my event that I'm going to store in Cosmos with an ID, order items in the order ID, and most importantly, the diagnostic ID, and the value of which is going to be the current activity.id, which is all happening in system diagnostics, which is basically where all the tracing and requests and spans and that sort of stuff originates in the .NET space. Now, on the other hand, so when I'm processing this, it's right here. This is where I listen for changes in Cosmos. And for each event, I do trace. And trace is a custom method that's looking like this. Again, I'll zoom in. Basically, we saw that I added an extra property to that JSON event that's going into Cosmos, the diagnostic ID. Now I'm just splitting it up, and I'm building an array of these trace parent type strings. For each event, I'm building that string, and since I'm going to be processing potentially multiple events, I'm shoving in an array, which with the interesting name _ms.links. Not sure why that is, but that's the way it works. And I'm setting that as a tag in the current activity. And that's basically it. Because then what that gives me, if I go back to the transaction search, let me find the proper transaction for this one, and again, I'm hoping I'm selecting the correct one right away. Yesterday, I think this would be a good one. Yes. So there, I'm within the order processor, I'm storing an event which is then linked to an order fulfillment processor, which is then also hooking up the request that happens there. And if you take a look at what operation IDs it found, it's not one, in this case it's two, but if I'm processing multiple events, it's going to be, well, more than that. And that happens because this is the request which has a custom property. Sorry, it's not the... Where is it? Where is it? I'm looking for that ms.links. There it is, operation links. It's actually giving it a proper name when it's surfacing right here, but if you just query the raw data in the requests table, it's the _ms.links, which is again the array of an operation ID and an ID. So now all my stuff is in there. And if I look at the different IDs that are all involved here, they're not sharing the same operation ID, which it can't because it's going to be a one-to-many relationship. But this child operation ID is having that set of MS links with the correct operation ID right there. And then but specifically, this ID that we didn't talk about before, but it's shorter string, that's actually the identifier of the dependency in the order processor. So the one that I created using the telemetry client, create dependency that has its own ID. And then if you then go all the way through the rabbit hole, that dependency also has a parent ID itself, which is the ID of the top level request. And this is the thing that I emitted into Cosmos. Why am I talking about these IDs, these identifiers? Well, because this is kind of where the move, basically the stuff that's inside the framework and inside the SDKs is converging towards the standard called OpenTelemetry. So that's where we go into the notion of, okay, maybe we're not living in a fairyland with only .NET and Azure. But these concepts of an overarching operation in OpenTelemetry is called a trace. And every single request or a dependency, there are spans. So a single trace through a whole system is composed of different spans that are all interconnected with parent-child relationships. So this dependency span is a child span of that request span, all within the same trace. That's the OpenTelemetry way of putting it. Does it still make sense? Yeah? Okay. Then what we talked about up until now is all .NET. And apart from Cosmos, where you have to build your own integration to make that work, if you would use the Event Hub for that same process, it would also work out of the box. But we're not all living in the .NET space, or not completely, and that's where OpenTelemetry comes in, which is basically, well, what is it? It's a set of SDKs to have consistent instrumentation of your workloads, meaning they're all familiar with that concept of of a trace and a span and what we just talked about, how you would interrelate those. They're all hooking into the W3C Trace Context standard that we discussed before. But it's also a OpenTelemetry protocol description of how you would communicate your telemetry stuff to an observability backend. Can be done either directly or through a collector. And that's not only working for your custom code, it's also working for or more infrastructure kind of concerns. They can all participate in this nice OpenTelemetry space where everything is now interconnected and traced. But we are at a Microsoft conference, or so I'm told. So, given what we already have in the Microsoft space, when would you use OpenTelemetry, or what is the place of OpenTelemetry in this discussion? Well, it has a future. Microsoft is also committed to OpenTelemetry as a standard. Microsoft is working towards first-class support in all different kinds of scenarios, but it's not quite there yet. And maybe that's because, well, in the Microsoft space, this has been around for some time. OpenTelemetry is distributed tracing is done. Logging is in the works, and metrics are also in the works. So there's still some work going on as well in the OpenTelemetry space itself. But then when it comes to Microsoft and its support for OpenTelemetry, as I said, there are different ways to communicate your OpenTelemetry data to a observability backend, so Azure Monitor on the right. One of them would be the OpenTelemetry protocol. So that would mean that, in this case, Azure Monitor would have an API, an endpoint, that's actually talking OpenTelemetry protocol, which it doesn't. Doesn't have that. As far as I know, this is also not really on the roadmap. But Microsoft is committed to OpenTelemetry, so there's some stuff that is on the roadmap and is coming. One of them would be to have this consistent collection of your telemetry data and then use the native endpoint protocol for Azure Monitor. So you wouldn't be talking OpenTelemetry protocol, but you would collect OpenTelemetry data and then use, well, whatever interface you have there to communicate that. However, that's generally available for Java, so maybe it solves your problem. For .NET and for Node.js and Python, it's still in the works. There's public preview SDKs available that you can use, but obviously using that in production is well, a choice you have to make if you would want to do that. So what you would then have is that you would have OpenTelemetry compatible collection of telemetry basically in your app, and you would send it over the native Azure Monitor API to Azure Monitor. Apart from having direct connections to the observability backend, you would also have the option in the OpenTelemetry space to use a collector. So basically an agent that's sitting in between, it's collecting telemetry data from different sources, amongst which your application maybe, and then sending that through to Azure Monitor. One benefit there would be to have that collector perform sampling, so that you don't do that on your endpoint, but you do it at the collector. So distributed stuff that's coming in there can be traced there. Can be sampled there. However, OpenTelemetry through a collector is also not officially supported by Microsoft yet. The model here, I didn't draw that in, but the model here would be that this is going to be OpenTelemetry protocol, and then this is going to be native calling into Azure Monitor. It's not officially supported. It does work. There are some collectors available that actually work for Azure Monitor, but again, if you're in an environment where you would want to have supported stuff only in production, this wouldn't work. So, I think all in all, if you're not, if you are in the Microsoft ecosystem for the better part of your stuff, it's maybe not yet a good idea to join the OpenTelemetry bandwagon. But it's good to know that basically whatever you do now in terms of distributed tracing kind of conforms to that same logic of, well, traces composed out of spans, using the W3C Trace Context header, etc., etc. So it's really converging to that OpenTelemetry stuff. I do think it's always difficult to predict the future, as we were reminded by Dennis. But I think in a year's time, we'll probably be using OpenTelemetry for this kind of stuff in the Microsoft ecosystem as well. I shouldn't mention periods, right, when I'm predicting the future. This is stupid. Okay, well, anyway, takeaways for today. Distributed tracing in the .NET space comes out of the box. So just basically look into your application insights, just really look at it and see what's already there. Because probably you don't need your custom correlation system or order IDs or user IDs to do distributed tracing. It's really converging to those open standards, W3C Trace Context, OpenTelemetry. It can be extended. You can hook up your own stuff. If support doesn't come out of the box, we saw Cosmos. You could also do storage queues if you would want to. And, well, take a look out for what's happening in the OpenTelemetry space. Because maybe it's not now the best bet if you're a Microsoft dev, but it's going to be. So don't miss out on that. Any questions, remarks?
Yeah, I got one. Can't remember which products they are, but in some parts of Azure Cloud you can configure legacy tracing instead of W3C tracing, Azure Tracing Context.
Yeah.
If you do that, does distributed tracing still work? I never check it, but
yes, but you're moving away from those standards where you this concept of this trace that's covering all your stuff and spans that sit in between, so requests and dependencies are spans. You're going to miss it. You're just shoving it all into one big operation ID, basically, because that's what the legacy tracing is.
yeah, so you're going to miss out on the breakdown.
Yeah.
Child-parent stuff.
Exactly.
Yeah.
Exactly. And you're missing out on usage of standards.
So actually I was looking into the IDs just the other day and I noticed that you have the ID, you have the root ID, you have the something ID, you have legacy ID. So they're shoving a lot of stuff into
Yeah.
a single object.
Yeah. Yeah. So well, that's maybe interesting to see. This really sums it up, right? I mean, this is a good way. I mean, it's discarding basically all the legacy stuff and it's just giving a clean overview. But just, I'm not sure what's going to happen, but just to see if I mean, obviously I have been using Postman to do stuff. Just let's see if they actually build up that graph nicely, because this is still a preview feature, I think. And now, obviously, this is not a widely used application, so it's that's not too bad. This is just a demo setup, right? So this is doing nothing for 2 weeks, and then again, all of a sudden, I'm doing stuff. And somehow, right here, obviously, what happens under the covers is for that single operation ID, it's making a goal to the Azure management plane to find all the application insights instances that hold information on that operation ID. I'm not sure how that will work, but it doesn't work flawlessly. So if after 2 weeks I'm doing a first request, then not all my traces are showing up here. They are all obviously in application insight. So if I just query them using the correct operation ID, it's all fine. But this visual representation, well, it is still in preview. I mean, I can leave the preview and then I will have nothing when it comes to visualization of distributed tracing. But that's something to look out for. It's really there, the identifiers are there, so you can build your own queries, but don't rely solely on this one, especially if your application, well, has its peak usages and then maybe dies down for some time. If you're building an election system for example. Then the first few flows don't really show up nicely here. But other than that, it's really available. Any other questions, remarks, comments? Yeah.
Is there any way to, you have a request that comes from the outside, you have an operation ID, that's generated probably the first time the request gets in. Is there a way to, if you have another system outside this, that also has an operation ID to pass that in the headers, for example?
Yeah. Basically, if it wasn't, if it wouldn't have been lazy, and I would have. Bad idea. If I would have built the front-end app, actually, that one would have generated a operation ID, which would have passed it on to the order API and so on and so forth. Simply through that same trace parent header. So if it's an external system that's making an API call to me, holding a trace parent header, that would also be instrumented as such.
Okay, but I mean, if you have, for example, that other application that is outside this is also pushing all the tracing to application insights, and that one has an operation ID. The moment that it leaves, for example, AWS, and it goes to Azure, how can you make sure that it remains the same operation ID? That's the point. So when you have multiple systems, they have to
I'm assuming then that the same operation ID would, I mean, the same operation in AWS or something, would actually make a call or send a service bus message or something does something to actually communicate with this particular system. If it's not, it's really not the same operation ID, right?
So you cannot pass that into HTTP header, for example.
Well, you could if you make that call from an AWS hosted instance, making a call to an Azure API, passing the trace parent header, then that's all fine. Then that works. It's really just HTTP. It's I think I'm between you and lunch, so this is probably a good idea to stop talking, to say thank you. Since I don't have video, I can't show you my GitHub account, but it is github.com/Annejan/finding the root cause. That's where you can find the code. Thanks very much. Enjoy your lunch, and if there's any follow-up questions, I'll be along for some time.